Okay, so the next part is going to be some different tests that they can do for heart activity, heart problems, and things like that. An EKG is named, I believe, because it was originally discovered in Germany, and cardio in Germany has a K, so that's why they call it an EKG. But you will hear sometimes people call it an ECG, which then is based off of the English spelling of electrocardiogram. It's basically a picture of the heartbeat. You'll see it on all the different shows that you might watch with medical dramas. And it says it detects the action potentials. Basically what that means is that's the electrical activity of the heart. So this is going to be helping to diagnose any diseases that might affect that electrical activity. The P wave in the diagram that you can see is this small little bump right here. And that P wave is going to be the depolarization of the atria. And instead of saying depolarization, I'm going to say it in a different word. Depolarization means that the atria are contracting. Okay, so it's a small little jump in electrical activity because remember the SA node gets fired, sends the message to the AV node, and you get the atria to contract. So it picks up electrical activity of the atria, and then you get that little bit of a bump. The next big bump is the QRS complex, and that one is really big. The QRS complex goes all the way up in this giant spike. The QRS complex is going to be denoting the ventricles contracting. And so it should make sense that you get a much bigger spike because think about the size of the heart, right? The atria are much smaller. They're only pumping blood down towards the ventricles. It's a very small distance, and they're going with gravity. Whereas the ventricles contracting, they're pumping, and they're supposed to push the blood out to the entire body. So that blood has got to go an awful long way to reach its final destination. So it needs to be a much larger contraction. It needs to be much more forceful, and the ventricles have much more muscle, much thicker, and much larger. So you get this big giant spike. The last thing is the T wave. The T wave you can see right here, and it's another smaller bump that comes afterwards, and that's going to be when the ventricles are kind of like resetting. And so the word they use for that is usually repolarization. Instead of saying repolarization, we're just going to do the basics, which is basically the ventricles are relaxing. There is an atrial relaxing as well. If you're wondering why you see atria contract here, ventricles contract, and then ventricles relaxing, it seems like we're missing the atria relaxing. But the atria relaxing actually happens during the QRS complex. It's just that it's such a small little bump that the giant spike from the QRS, from the ventricles contracting, basically covers it up, so you don't see it. All right, next is auscultation. Auscultation is basically listening to your heartbeat. So your doctor and nurse will do this every visit that you go to. They're going to use a stethoscope, and that stethoscope is going to allow them to listen to your heartbeat. The sounds that they hear sounds like lub-dub, 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 lub-dub. One is a little bit louder than the other, but basically it's the opening and closing of the valves. The closing of the valves is what causes the sound, and so a trained doctor, a trained technician, is going to be able to make something of that. And if you actually go online, you can Google heart sounds or abnormal heart sounds, and you can hear different examples of normal heart sounds and abnormal, and it's usually fairly obvious. A lot of times you hear like whirring or whooshing and an abnormal one. So the first sound is what they call the lub. I don't know how they would spell that, and that is going to be the closing of the first set of valves, which is going to be the AV valve. Remember, those are between the atria and the ventricle, so this is the blood moving from the atria to the ventricle. The second sound that they hear when the lub-dub is going to be the closing of the semilunars. And remember, the semilunar valves are the aortic semilunar and the pulmonary semilunar. And those are the ones that are exiting the heart and bringing the blood out to the pulmonary artery to go to the lungs or out to the aorta to go to the body. All right, blood pressure is next. We talked about blood pressure a little bit already. Normal blood pressure is going to be 120. What they'll say is over 80. So they'll give you a top number and a bottom number. It kind of looks like a fraction. The top number should be higher. These numbers are measuring the force that the blood is pushing on the walls of the vessels. So force of blood on vessel walls. I posted a really good video on blood pressure on Schoology, so you should watch that. It's really quick. It's 5 or 6 minutes, and it's a really good one. Talks exactly about it, and it shows some good pictures and animations at the same time. The two numbers that you're going to want to know are that what the top number and bottom number are called. I know we talked about this a little bit already. We've got systole, and then we've got diastole. Systole is when the heart is contracting, and diastole is when it's relaxing. So resting or relaxing is another way to say that. I'll put that right here. When the heart contracts, when the ventricles contract, the blood is pushing against much higher because it's all rushing out. And so you're going to have a much higher number like that 120. When it's relaxing, the blood is still coming out a little bit because it takes a while for all the ventricles to kind of empty, but it's much slower. So it's going to be a lower number such as 80. And you can hover a little bit below that and still be totally fine. You can be a little bit above that and be fine. But once I believe it gets to 140 on the top, and then I think 100 on the bottom, they call that hypertension, which is high blood pressure or chronic high blood pressure, where it would be putting too much stress on your heart, and they would be worried that it's going to cause your heart to wear out sooner. So they might put you on some medication. All right, cardiac output is the amount, so I'll just abbreviate that like that, of blood pumped per minute. So how much blood is your heart able to pump out every minute? If your heart is working efficiently and well, the number should be a certain amount for a healthy person. If it's lower, they're worried of a couple things. They're worried that every time your heart beats, it's a weaker contraction and it's not pumping out enough blood to kind of maintain your body activity. If it's too high, then maybe your heart is working too hard and it's putting too much stress on your arteries and blood vessels. Peripheral resistance we don't talk about too much, so I'm not worried about that. You could actually cross that off if you want. I don't ask anything on that on the test. Blood volume is just exactly what it sounds like. It's the amount of blood in your system at any given time. And so I think it's 5 to 6 liters in your body that an average person has, depending on an average adult. Okay, next up is a sonogram. A sonogram is, usually people think of this when you hear about a baby, like an ultrasound. So this is basically like an ultrasound. It's just of the heart instead of a baby. So this is an ultrasound of the heart. Things that they're normally looking at is the chambers and the anatomy. Remember, we have 4 chambers. They're looking at the septum, which is that dividing line between the two sides. So they're looking to see, is the septum there? Is the septum there? Some children are born with a hole in their heart, and what that means is there's a hole between the atria on the top in that septum or in the ventricles, and so that would be allowing blood to leak back and forth, and so that would be bad. Another thing that they could be looking at is the thickness of the muscle. If it's too thick or too thin, that might be too thick would usually mean that your heart is working too hard, and that's actually a bad thing. Too thin means that your heart doesn't have enough muscle, another bad thing. They might be looking at the valves and seeing if the valves are opening and closing properly. So all kinds of different things that a sonogram can show. Angiogram is next. An angiogram is a test where they actually inject dye. They usually go near your upper leg and the groin area, and they'll inject dye into your blood vessels. Well, once the blood starts moving, that dye gets carried all throughout your body. And so then they're going to be doing a test on the heart and looking to see, well, I guess they could look anywhere, but generally they're looking near the heart, and they're looking to see if there's any blockage in any of the blood flow. So let's write that down and I'll explain that. Checks for blood flow blockage. So for example, you can see that the dye here is going all throughout these areas. If they were worried about a blockage, they might look, and if they see that the blood flow all of a sudden stopped right here, and so they saw blood and they saw the dye moving, and then it stopped. But on this one, they saw it going all the way down. They would wonder why there was no blood flow of this area. And so they would see that there's a blockage. They would try to figure out what it is and then figure out how to fix it. They can do some different things to fix it, which we're going to talk about next. An angioplasty is one way to fix some of those blockages. An angioplasty can do a couple different things. It's basically, the main purpose of it is to get blood to keep flowing again where there was a blockage. So it's going to restore blood flow in a blocked area. It's going to be generally a blocked artery. So restores blood flow in a blocked artery. They're going to thread a tube really thin through a blood vessel, usually again like the armpit area or the groin, and then they're going to thread it all the way through the body to wherever the blockage is. Once they get to the blockage, there's sometimes a little camera at the end. Then they're going to do something to get rid of the blockage. So one of the things they can do is inflate a tiny little balloon, and that's called a balloon angioplasty. So right here you can see they're got this balloon area. They start inflating it, and it pushes out against the walls of the blood vessel, and it basically also pushes out against the blockage. Oftentimes it's a plaque buildup, which is cholesterol and fatty substances, and it basically squishes all that plaque so that it's not taking up as much space. So then it restores blood flow to that area. Another thing they can do is they can actually insert and leave a wire mesh. So you can see this wire mesh here. It's called a stent, and it's like spring loaded, and it props open, and then it allows for the artery to stay open. Sometimes they'll do that if you have a collapsed artery, and then they just keep that stent in place. There's a couple other things they could do, like a laser angioplasty, and this is where they use lasers to basically destroy the plaque that would be building up in your arteries, and then it causes the artery to be wide open again. In this picture, you can see that they're doing it in a coronary blood vessel, so that this person would have restored blood flow to that area of the heart. You can see this dusky area over here where it's a little darker. It's not getting as much blood flow. They want to open up those arteries so that the blood flows freely to those areas.